Hello students, good evening students. Now today I am explaining you JEE Mains 2024 session question, that is the correct stability order of the carbocation. Carbocation stability based question. What are the carbocations are given here? Once look at here: trimethyl carbocation, ethyl carbocation, isopropyl carbocation. This is methyl carbocation. So carbocations. On the carbon, what is the charge is present? Positive charge is present. So simple example for carbocation is methyl carbocation. Around the carbon in methyl carbocation, how many hydrogens are present? 3 hydrogens are present. Around that carbon, how many electrons are existing? 6 electrons are existing, each bond having 2 electrons. 6 electrons are present. 6 electrons means that is electron deficient. So carbocation is electron deficient. Whenever in the molecule at central atom less than 8 electrons are present, that is electron deficient, that is unstable. Electron deficient, the molecule is unstable. After 8 electrons are present, basically it is stable. So carbocations are unstable. Here to these carbocations, CH3, CH3, CH3. 3 alkyl groups are connected, that is methyl group. Those are methyl groups. CH3, CH2 plus. 1 methyl group is connected. Here CH3, CH, 2 methyl groups are connected to that. Here 1 methyl group. This is methyl only, methyl carbocation. So observation of these 4, 1, 2, 3, 4, which is the most stable carbocation. So stability of these carbocations, these are the saturated carbocations, aliphatic carbocations. These carbocation stability explained based on inductive effect. Inductive effect. So what is it? So these carbocation stability explained by inductive effect. Based on the inductive effect, I am telling now hint. So based on the inductive effect, minus I groups increases, carbocation stability decreases. Carbocation stability decreases. Plus I groups increases, carbocation stability increases. This is the common hint for aliphatic systems. Aliphatic cases, carbocation stability. This is the common hint. Minus I groups are increases, carbocation stability decreases. Plus I groups are increases, carbocation stability increases. So what is the inductive effect? First of all, students, I am explaining you briefly. Inductive effect. The inductive effect means it is observed in saturated carbon chain. Here the carbon chain is present, all are same electronegative elements. The sigma bonding electrons not moving either this direction or this direction, because of all are same electronegative element. The 2 bonding electrons existing exactly center to the both the nucleuses. To this carbon chain, for suppose different groups are connected, based on the nature of the connectivity of the groups, inductive effect 2 types: plus I effect and minus I effect. Plus I effect and minus I effect. Plus indicates positive, negative indicate, here the minus indicates negative. To this carbon chain, for suppose oxygen is connected, oxygen having the negative charge. To this carbon chain, NH is connected, NH having negative charge. Here oxygen, more electronegative elements having the negative charge. Negative charge means that is extra electron density. So to this saturated carbon chain, oxygen or nitrogen, that means NH is connected, the extra electron density moving towards the carbon chain. So on the carbon, what is increases? Negative charge increases. Here which carbon is nearer to the NH group? That carbon gains more electron density, negative charge. Here it is less electron density gaining. So these groups are connected, electron density moving towards the carbon chain. This group loses electron density, that's why they are called plus psi groups. That is plus psi effect. NH losing electron density, that is the representation of the plus. What is the minus psi effect? Here to the carbon chain or suppose more electronegative element, fluorine is connected to the carbon chain, the group of atoms, that is OH is connected, oxygen is a more electronegative element, OH. Here to the carbon chain, oxygen or fluorine is connected. Due to more electronegative in nature of the fluorine, the sigma bonding electrons moving towards the fluorine side from the carbon chain, sigma electron density moving. So what about here? More positive charge existing. Which carbon is nearer to this group or atom, more electronegative atom? This carbon loses more electron density. So that is minus A effect. Why we called minus A effect? Fluorine gains the electron density. So negative charge is existing here the more. These groups are gains the electron density. So which groups are considered as minus I groups? Fluorine, more electronegative element, chlorine, OH and NH2. So these are the neutral cases, and also OR also minus I effective group in the saturated system. I am saying saturated system. Here plus I groups examples, on more electronegative element negative charge is present, they are act as a plus I groups. And also best example for plus I group is R. R indicates what here? Alkyl group. Alkyl groups. Alkyl groups are the best example for plus I groups. Alkyl group example, CH3 is the best example, CH3, CH2 is the best example. So to the carbon chain alkyl group is connected. The role of the alkyl group, here the positive charge is present for suppose. The role of the alkyl group here, push the electron density, sigma bonding electron density towards the carbocation side, electron density moving towards the carbocation side. Now positive charge density, what happens here? Decreases, stability increases. Whenever positive charge on carbon decreases, stability of carbocation increases. Stability of carbocation increases. This is the key point. Positive charge on the carbon decreases, stability of carbocation increases. When positive charge decreases, if they are connected to plus I groups, alkyl group or more electronegative elements having the negative charge, they are connected to the carbon chain. Positive charge density on the carbocation decreases, stability increases. So plus I groups here, plus I groups increases the stability of carbocation, minus I groups decreases the stability of carbocation. Here based on that point, among the four molecules, here given molecules, this is tertiary butyl carbocation, this is primary carbocation, this is secondary carbocation, this is methyl carbocation. Here how many alkyl groups are connected here? 3 alkyl groups are connected. How many plus I groups here? 3 plus I groups. So plus I groups are increases, stability of carbocation increases. Here 1 plus I group is present, here 2 plus I groups. This is tertiary carbocation, secondary carbocation, primary carbocation, this is methyl carbocation. So what is the stability order? Stability order: tertiary, secondary, primary and methyl carbocation. Okay now students, so the key hint is here, plus I groups are increases, stability increases. Plus I groups are alkyl groups, on more electronegative elements negative charge is present, they are act as a plus I groups. Okay students, I hope you are understood. If you are not understand, ask me. In the later videos also I am explaining previous mains questions based on the carbocation. Okay students, bye students.